On today's Do Now, we're going to find the slope of the line that passed through the given points, 7, 9, and -3, -3. I gave you a hint that you might want to use the table method. You could also use the equation method if you wanted, but I'm going to use the table method. So with the table method, we're going to put our x's and y's in the tables as we see them. So I'll put our first point, 7, 9, and then our second, -3, -3. Now we know slope is our change in y over our change in x. So we're going to look for how do the y's change? How do we go from 9 to -3? Well, we must have subtracted 12. So our y's change by -12. How do the x's change? How do you go from 7 to -3? -10. So that's going to be -12 over -10. Negative over a negative is a positive. There's a common factor of 2, so it's 6 over 5. Okay? Now some of you might be saying, oh, can I change it to a mixed number? It looks better that way. No, we're always going to write slope as improper fractions, never mixed numbers. The improper fraction gives us more information that we're rising 6 spaces and running 5. 1 1/5 doesn't provide that same information. I want to start today by going over some of the problems from Friday's classwork on page 19, number 4. The origin 0, 0 is one of the points on a line. Plot another point so that the slope of the line is the value shown. Draw the line. So we're going to draw a line with a slope of 4. We know the line goes through the origin, and we have to make another point so we can draw a line. Now, having an integer of 4 doesn't really help us, right? Slope is our rise over our run. We structure it as a fraction. So the first thing I want to do is rewrite 4 as a fraction, as 4 over 1. That tells me we're going to rise 4 in the positive and run 1 in the positive. So I count it out. I go up 1, 2, 3, 4, run 1 to the positive. There's my point. Now I can go ahead and create my line that shows a slope of 4. On B, -4, we're going to write as -4 over 1. That tells me we're going to rise 4 spaces down. So we're going to go down 4 spaces and then run 1, +1. So it's going to go to the right. So our starting point at the origin, we go down 4, 1, 2, 3, 4, to the right 1. We're going to get a line with a nice negative slope there, going down the mountain. Okay. And our last problem, -1/4, when we write that, we have to decide where to put the negative. Do not put the negative in line with the fraction bar. Pick, either put it in the numerator or the positive, or the denominator. I'm going to put it in the numerator. This tells me we're going to go down 1 space and then to the right 4. Had you kept it in the middle, some students get confused and think both are negative. No. The fraction is negative, so just 1 is negative. Put it to the numerator. So we start at the origin, go down 1 to the right 4. Okay, we get a nice shallow line. Not very steep at all. Okay, and that's a great pre-step as to what we're going to do today. Today we're going to graph using the slope-intercept method. So we're not going to use a table of values anymore. And I think when you get used to this, you're going to really like it. So Friday we talked about slope. We set an equation y equals mxb plus b, that the m was the slope, that it tells us the rise over the run. The b, what we had previously called our initial value, is our y-intercept. The number that is b tells us where the line touches the y-axis. And when we graph, that's always going to be the first point we use. Okay, so we're going to plot the y-intercept as our first point, and then use our slope as our directions to our next point, like we just did on that previous example. Okay, so we're going to use our y equals mx plus b form. Okay, y equals 3x minus 1. I can see that 3 is our slope, and then negative 1, you take its sign, is our y-intercept. So that means our line is going to start at negative 1 on the y-axis. Our y-intercept is going to be the ordered pair 0, negative 1. All points on the y-axis have an x-coordinate of 0. Our slope, notice how we structured the line here. Change in y over change in x. There's a fraction bar there. Whenever we have an integer slope, we're going to rewrite it as a fraction. So 3 over 1. This second line here is to show you could also do your slope as negative 3 over negative 1, sort of working backwards, but I don't think we need to do that for our example. Okay, so we've got our starting point, negative 1. Boom, there's our y-intercept. That's where we're starting. Now we use our slope. Slope is the directions to the other points. Okay, so our slope tells us go up 3 because it's a positive, right? That tells us up 3 to the right 1, and we're going to count it out. Don't draw boxes. Count it out. We go up 1, 2, 3 to the right 1, put your dot. 1, 2, 3 to the right 1, put your dot. And we keep going 1, 2, 3 to the right 1 until we run out of room on the coordinate plane. Then we go and do the opposite. We're going to go down 3 to the left 1, which is essentially that negative 3 minus over negative 1. We're going down 3 to the left 1, down 3 to the left 1, down 3 to the left 1, down 3 to the left 1. So once we're at the y-intercept, kind of skip ahead to the y-intercept, we're using that reverse slope to make the rest of our linear line, our straight line. So we go down 1, 2, 3 to the left 1, 1, 2, 3 to the left 1, 1, 2, 3 to the left 1. And then we create our line. And we label it y equals 3x minus 1. Some of you might be asking, do we have to make all the points? Can't you just make the line once you have 2 points? Yes, you could just make the line when you have 2 points. Yes, you have to plot all those points. Plotting every single one of the points is going to be really important when later on in the week we talk about solutions of equations where we have an intersection point and when we get into graphing inequalities. Okay, and I just want to go here and point out that that point, that was our y-intercept, which was our starting point. Okay, so let's take a look here. We've got 2x plus 4y equals 16. What's the y-intercept? What's the slope? I don't know. It's not in slope-intercept form. So first thing we have to do is put in slope intercept form. So we have to isolate the y. That's why we've been practicing that all last week. So to isolate the y, I'm going to subtract 2x from both sides. 4y equals negative 2x plus 16. Now I divide both sides by 4. Y equals negative 2x divided by 4, we're going to reduce, we're going to say that's negative 1/2 x. Notice how I already put the negative into the numerator. 16 divided by 4 is 4. So from here, I should be able to identify, ooh, there's my y-intercept. There's my slope, just from knowing our y equals mx plus b. So our y-intercept is going to be at 4 on the y-axis. So the ordered pair 0, 4. And our slope, negative 1 over 2, which means we're going to go down 1 to the right 2. And then if we think of that as its opposite, would be a positive 1 and a negative 2, which would tell us go up 1 to the left 2. Okay, so let's find our starting spot, our y-intercept, the point 0, 4. Now I'm going to follow my slope, -1/2, go down 1 to the right 2, 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 down 1 to the right 2. Ran out of space. Now we go back to the y-intercept and do the opposite. Up 1 to the left 2, 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 up 1 to the left 2. Okay? Now from there, we can construct our line. Right there. Okay, and then label our equation. It's a very simple way to graph. All we have to do, find the slope, find the y-intercept, start at the y-intercept, use our slope to get to the next point. On the following page, we are going to do exactly the opposite. This time, we are given the line, and we need to write the equation. In order to write the equation of the line, you need two things. You need to know the slope, and you need to know the y-intercept. We're going to write it in y equals mx plus b form. Okay? So first thing I like to identify here is my y-intercept, because it goes right through the y-axis. That's easy to see. Our y-intercept is at -2, so it's -2. So far, I know I'm going to have a y equals something, and then a -2. Now we need to find the slope. To find the slope, we have to find another point where it goes perfectly, the line goes perfectly through the corners of the boxes. So that's here. I'm going to tell you that's where it is. It's the ordered pair 3, -3, so you can do it on your own paper. Now I'm going to use that rise over run method for our slope to find it. So what are my directions? I would tell you go down 1, so -1 in our rise, and then go to the right 3, so +3 in our run, which makes our slope -1/3. Okay? Now some people might ask, well, I didn't see that as the point. What if I saw 6, -4 as the point? Well, it's going to be the same thing. You're just going to rise 2, run 6, -2/6 reduces to -1/3. Okay, so now we know the slope, we know the y-intercept. So all we do is take that information, substitute it into the equation, put in -1/3 for our slope, -2 for our y-intercept, making the equation y equals -1/3 x minus 2. And that's the equation of our line. Okay? Each line would be unique with the combination of slope and y-intercept. Let's look at this one here. So first thing I should realize, we've got a horizontal line. And that's special, right? I might pop into my head what we talked about, VUX-OI, right? Vertical line, undefined slope, x equals equation. OI, horizontal line, 0 slope, y equals equation. Okay, so we know we have a 0 slope. Then we look for our y-intercept right there. It's 7. So even if we think about substituting into y equals mx plus b, we would have y equals 0x plus 7. 0 times x is 0. 0 plus 7 is just 7. So our equation, y equals 7. But using our VUX-OI, knowing the special of a horizontal line, we can jump right to saying y equals 7. If we see a vertical line, we have to know it's an x equals a number equation. You can't even substitute in and kind of get it that way. Okay, so on your classwork today, you're going to do some graphing. Okay, first step, you have to make sure your equation's in slope-intercept form so you can identify the slope and the y-intercept. You always start, your first point is the y-intercept. Then use your slope as your directions, up and over, down and over, to get all your points. Okay? When going and writing the equation, identify your two key pieces of information, slope and y-intercept, and then substitute into that y equals mx plus b form. Today's math jokes for Matthew folks. Why does nobody talk to circles? Because there's no point.